So I am Adam Skewgar. I'm in the Azure product group. I work in media entertainment, and I focus on content management. Give you a little bit of an overview of Azure Storage today. We only have about 10 minutes, so we'll be pretty quick. I'll leave some time for questions. Starting with Azure proper, we're in 54 regions around the world now. That's more than twice as many as the next two closest cloud providers. We're committed to that and continuing to bring those regions as close to our customers as they need us to be for all the data sovereignty and latency requirements that they have. We've got 4,500 peering locations around the world now, and that's all about making sure that our network can meet where your network is. And then you can take advantage of the Azure backbone instead of traversing over the public internet, as some other solutions would have you do. Azure Storage itself is composed of three primary storage primitives. There's disk storage, which are the persistent disks for virtual machines in the cloud. On the other end of the spectrum is file storage. We have our own native file service that we run. And then we have a file service that we're going to be offering with NetApp. We've announced this, but we will offer it as a first-party service. So if you're taking advantage of ONTAP today, you can have an instance of that running in Azure operated by us. In between is Azure Blobs, and since we're at a media event, it's blob storage that is usually the most discussed because it's the appropriate place for unstructured, scalable content. So we'll spend most of our time today talking about that. Before I go on, we also have data transport capabilities. I've got a full slide. I'll show you how we think about bringing content into the cloud, again, in the media business in particular. Tens or hundreds of petabytes of data movement are not uncommon. So we'll talk about how we approach that. And then we have a variety of hybrid storage solutions. We have a file synchronization service that works with Azure Files. Acts as a cache for your data on-prem. Similarly, with Avere, we have a high-performance file system cache usually used in rendering workloads. We'll get a little into Blob itself. Again, as I said, the most common file storage use case in media entertainment. So within Azure, in your tenant, as we call it, we have the example company Contoso here. You create subscriptions, and subscriptions are the highest level boundary of permissions, so that you might have one subscription for the entire company, or you might have subscriptions that you work by department or project. Within a subscription, you create storage accounts, and that's the boundary of all things storage. You can deploy files and disks and blobs within that. For blobs in particular, you deploy a container. You can have multiple containers to separate storage, and then you store blobs within those containers. And I don't think I've said this, but I should mention, in case the term blob is new, some people would just say object storage. It's the same thing, just we call our object store blob storage. So you store blobs in your containers, and then an individual blob is addressable via a predictable URL that contains the storage account name, the container, and the individual blob you're trying to put or get. And we have three different types of blobs. The most common type of blob is the block blob. It is optimized for sequential reads, though of course range reads are supported. If it is smaller than 256 meg, you can store it in a single put blob operation. If it's larger than that, up to 5 terabytes, you would break it up into blocks, and then you store a sequence of blocks within a blob. We have append blobs. And append blobs are really optimized for append-only scenarios, so you can think about logging or the output of analytics. And it's multi-writer scenarios where you're just assuming that it's always append. That contrasts with block blobs, where you can update a blob after you write it. And then finally, we have page blobs. For the most part, page blobs really only show up as the underlying infrastructure in our persistent VM disks. But they can be used natively, and there are some situations, like if you need to store sparse files. They're really well optimized for random reads. So there are good reasons to use page blobs, but it is the least common use case. From a durability perspective, we take zero data loss as a really serious requirement for us. You just have to trust that, we want you to trust that anything you store in Azure is just going to be there for you. So part of the durability promise that we make is how we replicate data. When you write data, the least redundant, what we call locally redundant storage, version of what we offer is equivalent to 3 copies. We're not actually storing 3 copies. We use an algorithm called erasure coding, which actually achieves better than dual parity RAID. You can read documents online. We've got papers published on what that means to help you understand it. And we are doing a synchronous write to all 3 replicas. It's within a single region. I showed you those 54 regions up front. We're doing a synchronous write. If we can't write 3 times, we're not going to acknowledge that that write comes back to you. We've since then offered zone redundant storage, and zone redundant storage is taking this to the next level. Instead of just protecting against the basics of a disk, a node, or a rack failure, we're taking it outside of that. You can think of this as the data center, but those data centers are close enough together that we can still offer that 3 synchronous writes before we acknowledge the write back to you. You're getting to the point now where you've got 12 nines of durability. That's a lot of nines. Geo Redundant Storage takes the 3 replicas in a single region and asynchronously replicates them out to a secondary region. We pair our regions, so when you pick a primary, we tell you what the secondary is. That's not a choice you make. But those are paired for that replication purpose. They're always within a geopolitical boundary, so we're not sending your data across the world. We're sending your data hundreds of miles apart. But still within that geopolitical boundary. And that's to protect against major things like earthquakes and other such events that could wipe out an entire region. You've got a region far enough away, and we make strategic decisions about how to place those to keep them in different fault areas. Now you're up to 16 nines of durability, and then we offer one more variant of replication where you get read access Geo Redundant Storage, or RAGRS. And the only difference between the read access version and Geo Redundant Storage is that the secondary is available to you for read operations, even if there's not a disaster. So for certain use cases, it's nice to be able to access that secondary for those read operations. In a failover, in the case of Geo Redundant Storage, we choose when to fail over. Your secondary becomes the primary. In read access, you can just access the secondary ahead of time. We have announced the ability for customers to control their failover as well. And there's more improvements coming to that process in terms of things like being able to drain the storage before you do the failover. We offer different, what we call temperatures of storage, or tiers of storage. Hot, cool, and archive are the ones we've had for a while now. Hot is your typical high-performance storage, where your expectation is you can frequently access the data. Cool storage actually has the exact same performance characteristics. You don't give up anything in terms of the throughput and latency when you go to cool storage. We're just making a trade-off on price there, where we charge you a lot less to store it, and we charge you a little more to access it. So it's just a trade-off in terms of where the cost is for us, and we can pass those savings on to you. Archive works differently. Archive, there is a delay. It's, again, much cheaper, but there's a delay in terms of the access to the data while we bring the data back to a cool or a hot tier for your read access. We do now support the ability to write directly to archive. So you do not have to come through a higher tier and then push to archive. You can certainly do that. But if you want to write directly to archive, you're welcome to do it. And we have a new offering in market, and this is the only thing like this that exists in the industry. It is an SSD-backed object store. We did this to build super high performance, low latency storage. So we're getting single millisecond latency up to 99th percentile. The only one who can do this for object storage. It's really great for things that are interactive, like think an editing session and your videos are in object storage, and can you do that real-time editing? That's the kind of thing that we optimized premium blob storage for. I talked about the 3 different tiers that we've had for a while now. The things that set us apart in the market are the fact that we have a single REST API that works across all 3 of them. You don't have to change your application behavior because you're deciding to use a new tier of storage. You get fine-grained control when you put a blob at any point in time, either explicitly with a set blob tier API call or through lifecycle management policies. You decide which tier of storage a blob should be in at any point in time, and you can move it back and forth between tiers. I mentioned up front that we have different ways to handle ingest of data into Azure. And the core of this product family started over on the left with the data box. It's a 50-pound shippable container. You go into the Azure portal, you order it, you set up some information about kind of connecting to your storage account. We ship it to you. It looks like a file share on your network. Load it up with up to about 100 terabytes of data and ship it back to us. We securely unload it into your storage account. This is great when the network just isn't available to sustain the kind of throughput that you would need to get that data into Azure. From the original DataBox offering, we went down to a DataBox disk, which is a little Pelican suitcase. It's got 5 USB drives in it, gives you up to 40 terabytes of storage. But it's a smaller, lighter form factor to deal with, but of course you're dealing with individual disks instead of a big box. And then we went up, and this is in preview now, to the 1 petabyte version. The 1 petabyte version called DataBox Heavy. You can try this in preview today. We do have customers that are using it. And in multi-petabyte scenarios, what we see is 2 or 3 of these heavies, and they kind of do round tripping where they're loading one of them while they're shipping another one to us, and we're unloading a third, and we keep these running in a kind of a circuit. And then we have some online data transfer capabilities. We have a DataBox Gateway, which is a VM that you deploy on your hardware of choice and your hypervisor of choice. And it, as a file share on your network, it also accepts blob storage API calls if you want to go native from that edge point. And it is going to keep a cache of what you write to that file share, and in the background stream that data up to Azure. We also have a DataBox Edge physical appliance version, and the advantage of the physical appliance is that it's also an edge compute platform. So it has IoT Edge on a custom FPGA, so that any Azure service that has an IoT Edge component can run on this DataBox Edge device. That's great for pre-processing data before you upload it. We've got an example in our booth where we're showing a transcode down to a smaller format file. The small format file can come up to Azure quickly for digital review, while in the background, based on your scheduling and throttling, you can get the full file up to the cloud. And if you have something that's not Azure IoT that you want to run on this device, as long as you can put that in a container, you can use the Azure portal to deploy it to this edge compute device as well. And that's all I had. I'll open it up for any questions.